Okay, so this chapter is your volume and surface area of prism and cylinder. Okay, so essentially we're going to learn formulas for two different types of shapes. Okay, your prism and your cylinder. Okay, so first thing as well, okay, we look at conversion of units. Okay, so from cm cube to meter cube or from meter cube to cm cube. Okay, so now because it is cube, okay, 1 meter is 100 cm. Okay, you are going to cube both of your meter and cm. Okay, so one cube is still 1, okay, meter cube. Okay, when I cube, okay, I cube the number as well as the units, right? So 100 cube you get 1 million, okay, because 6 zeros. Okay, then cm becomes cm cube. Okay, so if I convert cm cube to meter cube, I just divide the 1 million over. Okay, that's why you have 1 over 1 million meter cube. Okay, so this example here is just an example of your conversion. Okay, from cm cube to meter cube, just divide it by 1 million. Okay, or you multiply it by the fraction of 1 over 1 million. Okay, same thing. Okay, then from meter cube to cm cube, just multiply by 1 million. That's it. Okay, so this is your conversion. Okay, because now in this chapter we are working with volume. Okay, no longer just area. Okay, that's why it's up to cubic centimeters or cubic meters. Okay, come, let's take a look at the formula for your volume and surface area of prism. Okay, so your prism, okay, essentially what a prism is, okay, the important thing to identify for your prism is the uniform cross section, which means the cross section that applies throughout the figure itself. Okay, so take a look at this prism. Okay, in your notes it is shaded for you which is the uniform cross section. So when I say uniform cross section, it means it applies this shape itself, okay, or this cross section applies throughout the entire solid itself. Okay, so the cross section applies throughout the entire solid. So for your surface area, okay, of course we have the top as well as the bottom cross section. Okay, that's why you have 2 times cross sectional area. Okay, what is this? Perimeter of cross section times height. Okay, so essentially the remaining cross section, or not say cross section, the remaining areas, surface areas that you need to account for. Okay, so surface area are essentially all of the outer faces. So for example, this is one face. Okay, this is another face. Okay, and because for this example given to you in the notes, this is a regular polygon, which means all of the sides of the polygon are equal. Okay, so if I were to ask you how many faces this has, okay, if you can visualize, this has 6 faces. 1, 2, 3. Okay, the one at the side here is a bit small. 4, 5, and 6. Okay, so 6 faces in total, but all of these 6 faces are equal because this is a regular polygon, which means all of the sides are of equal length. So if we just look at one rectangle, okay, it is your length times breadth, right? But I have 6 times of it. So essentially it's 6 times your length times breadth. Okay, so when they say perimeter of cross section, essentially I'm counting 6 times of the breadth multiplied by height, which is the length. Okay, so let's write it out to better visualize it. Okay, so I have 6 times of your length times breadth. Okay, where the length is the height here. Okay, so let's make it easier to compare. Okay, instead of writing length, I'll write height. Okay, then the breadth is essentially the side of the polygon here. Okay, so instead of writing B, maybe put S. Okay, so if I were to compare it to this, okay, perimeter of cross section essentially is 6S, right? Because 6 times of the sides of the polygon. Okay, because in this case, this is your 6-sided polygon. Okay, which means the hexagon. Okay, times the height here, which is the length of a rectangle we were talking about. So times H. So essentially, these two are equivalent. Okay, that is why you have this short form or direct method of using perimeter of cross section times height. Okay, so if you don't, or if you are confused, okay, it doesn't matter, you don't have to use this, because sometimes the exams, the questions have different scenarios. Okay, just look at the faces individually, and if they are the same, just multiply by the number of times that you have. Okay, which is the first method I did. Okay, not all the time you have to use this portion here, or this formula here. Okay, next, volume, very straightforward, just cross-sectional area times height. Okay, so for your prism, okay, there are different examples of prism. Okay, you could have a triangular prism. Okay, a cube is also a type of prism because you have a uniform cross-sectional area. A cuboid is also an example of a prism. Okay, so prisms, there are many different variations. Okay, so ultimately what you all need to know or remember and apply is the formulas of volume and surface area. Okay, more importantly, your volume. Okay, which is the cross-sectional area times height. Okay, surface area, if there are too many different faces in the questions given to you in the exams, okay, you can just identify the different faces one by one and then add them up together individually. Okay? Okay, so with that in mind, let's take a look at the example that you have in the next page. So let's take a look at example 13.2a. Okay, so you're applying your formula for surface area and volume of prism itself. Okay, so part 1, you are asked to find the volume of the prism. Okay, so when you want to find the volume of a prism, okay, you first need to identify what is the uniform cross-sectional area, which means the cross-sectional area that applies throughout the entire solid itself. Okay, so the one that you should identify as your cross-sectional area, okay, is this red outline that I've highlighted out in the diagram itself. Okay, because this shape itself applies throughout the entire figure. Okay, so this yellow area that I've shaded with the red highlight, okay, this is your cross-sectional area. Okay, so now you need to find out what is your cross-sectional area. Okay, so nowhere in your syllabus of math have we taught you a formula for such an irregular shape. Okay, so in your questions, you need to split them up into the shapes that we already know how to calculate. Okay, which means for this example, I need to split this up into a rectangle and a triangle. Okay, so your first area of rectangle, okay, 10 times the 5 cm here. Okay, you get 50 cm square. Your triangle, okay, you have to go and work out what is your base and height on your own, because this is something that we broke up in the figure itself. Okay, so if this entire chunk is 5 cm, okay, this is 9 minus 5. That's how you get the 4 here. Okay, so you can just annotate on your diagram 4 cm. Your height is essentially the 10 cm here minus away the 6 cm that you have here as well. Okay, that's why you also get a height of 4 cm. Okay, so your area of triangle is half times base times height, which is half times 4 times 4. Okay, 8 cm square. Okay, sum up your total base area. Okay, you get 58 cm square. Okay, so what I want to highlight before I move on is in this portion, okay, or in any working of your math, okay, please always write your statements. Okay, this is very important, your presentation, PP, okay, in your questions itself. Okay, next, what is your height of your prism? Okay, so if this is the cross-sectional area, okay, your height will be this 7 cm over here. Okay, so volume is just your 7 times 58, 406 cm, okay, cube. Okay, help me change it. This is cube, okay? Okay, next, your total surface area. Okay, so total surface area, essentially, you need to look at all of the different faces that you have within this diagram itself. Okay, so in total, this diagram, there are 6 types of rectangles and 1 type of triangle. Okay, so let's try and break it down together, the different shapes that you have. Okay, so the first rectangle that you have, okay, obviously would be this rectangle here. Alright. Second one, okay, which I have two of it. Okay, I'll do it in a different color. Okay, this rectangle here. Okay, and I have two of it because on the other side, I also have one more of it. Okay, so 2 times of it. My third type. Okay, let's do it in blue. Okay, is this rectangle here. Oops, sorry. Okay, let me redraw the one that I highlighted in black just now. Okay, so we have 3 so far. Fourth one, okay, this slanted one here. Fifth, okay, the base here. And the last one that I'm looking at. Okay, let me see if I can find a different color. Okay, this big one at the side here. Okay, maybe let me use it. This one is too thick. Okay, let's just do it in red again. Okay, over here. Okay, so in total 6. Okay, then you have one type of triangle, which is the triangle here, and I have 2 of it. One over here, 2 over here. Okay, so in your exams, you have to go and break it down like that for yourselves. Okay, so just look at the individual areas and write them out first. Okay, then help me add in something here. This should be surface area, not area. Okay, so you have the broken down, okay, of all the different faces that you have. Okay, then please, okay, one thing I want to highlight, okay, although we just write out the final answer here in your exams, go and work out the individual values here, which means, for example, this one will be 100, okay, this one will be 70, 35, 42, 56, 9 times 7, 63, 4 times 4, 16. Okay, go and work out all these individual values first. Okay, then you sum them up. Okay, please don't key this whole chunk in your calculator. You just need to key one value wrongly or one sign wrongly. Okay, even if you get the wrong answer, the calculator won't tell you that, because as long as you are able to compute a value in the calculator. Okay, so please write out the individual values first. Okay, then you sum them up. Okay. Okay, let's take a look at this example now. Okay, finding your unknowns, which means maybe they give you a value for the volume or the surface area. Then you are asked to find a certain value. Okay, so given that the volume of this figure shown is 336 cm cube. Okay, let me change this to cube. Okay, find the value of h. Okay, so what is this h here? This h is the height of your triangle, right? Perpendicular height. Okay, so look at this diagram. This is an example of a triangular prism. Okay, so the cross-sectional area that I'm looking at in this scenario essentially is this triangle here. And the height you are looking at is this 12 cm. Okay, which is the height of the prism itself. So, given that this is the volume, I need to equate the formula to the volume, which is your base area times height, right? So your cross-sectional area in this case, which is the base area, is half times base times height, alright, which is half times h times 6 here. That's what you have. Okay, your height here of your prism is 12 cm. So essentially, this base area times height, or your cross-sectional area times height, is equivalent to your volume of 336 here. Okay, so they equated the 336 to your 36h, which is worked out from here, half times h times 6 times 12. Then from there, very simple, okay, just move your terms around. I'm gonna divide the 36 over. Okay, so you have 336 divided by 36. Okay, you get 91 over 3. Okay, sorry, there's a typo here. Let me add a 3 here. It should be divided by 36. Okay, that is for part A. Let's take a look at part B together. Okay, part B. The figure shows a heart-shaped prism which has a volume of 250 cm cubed. Find the area of the shaded region if the height of the prism is 15 cm. Okay, leave your answers corrected to 3SF. Okay. So, okay, same thing in this scenario. I am given a volume. Okay, and you are asked to find the area of the shaded region. Okay, so this shaded region, essentially, this is your cross-sectional area. Okay, the area that is uniform throughout the solid. Okay, I know my height is 15. So volume is your cross-sectional area times height, right? So this volume of 250, it is my base area of the heart itself, the heart shape, times 15. Okay, so just divide the 15 over, you get 250 over 15. Okay, and then you get this recurring decimal here. Okay, I'll not say recurring decimal, sorry. 16.6667. Okay, and then because they want your answer in 3SF, okay, put it in terms of 3SF, you get this value of the base area itself. Okay, so whenever in the exams you are given such information, okay, always think back to what are the formulas you have learned for surface area and volume. See if you can apply them. Okay, because you have never been taught how to calculate an area for a heart shape, right? Okay, so if you are lost, always fall back to what you have learned. Okay, which is the formulas of volume and surface area you have learned. Okay, so that is for your prisms.